Okay. So our CBA 2 is coming up. And so I wanted to go over some of this review. We've already gone over it. Your students should have their own copy. Um, but we're going to go over it again just in case. Especially when it comes to certain strategies for test taking. Okay, so let's talk about question number 1. It says which expression is represented by the model below. Okay, so I know that in class the first thing I had them do was write down PEMDAS. Or not PEMDAS, sorry. The first thing I had them do was write down their rules for multiplying positives and negatives and multiplying numbers with the same signs. So a positive times a positive gives you a positive. A negative times a negative gives you a positive. A positive times a negative gives you a negative. And a negative times a positive gives you a negative. I'm going to say same sign. Different signs. Okay? So I'm writing that down because if I look at my the model, my number line, I see that there's nothing in my positives. It's all in my negatives. Knowing that, I can say, well, a negative times a negative times a negative is a positive. But am I representing a positive answer here? No. So we're going to cross it out because that's not going to work. Negative 5 times negative 6 gives you 30. We're not looking for 30. We're looking for negative 30. G, 6 times negative 5. Well, here we're going to see what we're skip counting by. We are skip counting by 5s, which is great. How many times did we actually skip count? Let's see. We went 1, 2, 3, 4, 5, 6. So I like G. I'm going to put an M right next to it for maybe, because I still need to look at the rest. 5 times negative 6, that still does give me negative 30 different signs. However, did I make 5 jumps of negative 6 or 6 jumps of negative 5? If I go here, 5, 10, 15, 20, 25, they're skip counting by 5, not 5s, not 6s. And I made 1, 2, 3, 4, 5, 6 jumps, not 5 jumps. So H tells me that even though our product will be the same, it doesn't represent our model above. Same signs will give me a negative or a positive product. We're not looking for a positive product, therefore J cannot work for us either. Going up. Here we go. All right, so number 2 is going to be, or it's going to begin with, Mickey, okay? So Mickey opened a brand new bank account in January, and he kept a record of the activity in his bank account. It says in January he deposited $100, but he withdrew $25, and in February he deposited $50, but withdrew $40. Question they want to know is which model best represents Mickey's balance at the end of these 2 months. So there's a couple things I'm going to do here. The word deposit, okay? To me that stands out a little bit because a deposit is always going to be a positive value. If they're saying that Mickey deposited $100 into his bank account, he added that $100 into his bank account. Now, to withdraw something is to take away. Well, we represent taking away as a subtraction sign. That's going to help me because now I need to figure out what's happening and how to write that as an actual equation. So in January, he deposited $100. That's going to give me a positive 100. But he withdrew $25. Um, 100 minus 25, that's going to give us 75. Then in February, he deposited $50. We'll get 125 with that. But then he withdrew $40. So we can solve 125 minus 40. 5, 12 minus 4 is 8. So he was left with $85 at the end of all of this. But they're asking which model best represents. And so we need to figure out which one makes the most sense. If I look at F, just because it's right by where we left off, I can see that here at 0, we deposited, we added $100, but then we withdrew 25. That means we should have gone back. But here, it has us going forward and forward and forward and forward, indicating that all we did was add. But he did more than just deposit, he also withdrew. Therefore, F cannot work. It's just wrong. G, it shows 2 steps, but we did 1, 2, 3, 4 steps. So is that enough steps? No. Plus, they deposited the 100 and then deposited some more. But according to our bank statement in January, we deposited and then we withdrew. So we should have added money and then taken some out. For H, we have 0, we deposited $100. Oh, but then it says we deposited more money. In January, we deposited and withdrew. We should have gone to the left. Here it has us going to the right, to the right, to the left, to the left. But we added, subtracted, added, subtracted. So H, unfortunately, is not going to work either. Our only answer that makes sense will be J. We added 100. We withdrew 25. We added 50. We withdrew 40. Okay. Awesome. Let's keep going. Okay, one morning, the outside temperature was 14 degrees below 0. So what does that look like as a number? If it's below 0, it's going to look like negative 14. I want to write with it, say something darker. All right, negative 14. By noon, the outside temperature had risen. If you don't know what risen means, it means it's past tense for rising, okay, to rise. So it went up. If it went up, then we are adding. It went up by 18 degrees. And then by midnight, the outside temperature had dropped 16 degrees. When you drop something, because of gravity, it always goes down. If we're representing something going down as a number, it's going to be represented as multiplication. So now, here we are, negative 14 plus 18. That can be viewed as 18 minus 14, which will give you 4. Drop our subtraction sign, drop our 6. If you have $4 in your bank account, but you spend $6, that means you have a negative balance, and your negative balance will be 2. However, in this case, They wanted to know what was the outside temperature at midnight in degrees Fahrenheit. Well, it was -2 degrees Fahrenheit. All right, let's go to the next one. Okay. For number 4, this is where I had everybody write PEMDAS. Because we have some of that stuff going on here. So PEMDAS, PEE, or PEM, DAS. I'll draw the symbols, parentheses, exponents, multiplication, division, addition, and subtraction. Okay. So we're going to do that first, okay? We're going to look for parentheses. Now, here we have parentheses, but there's nothing happening in between them, which means that the numbers within these parentheses are essentially already simplified, okay? So we're just going to work with our PEMDAS first. We don't have parentheses that we need to do work in. We don't have any exponents. We don't have multiplication, but we do have division. And that division is right here at 33 divided by -3. Different signs, positive divided by a negative means my answer will be negative. And 33 divided by 3 is 11. I'm going to put these in parentheses because I'm going to bring up my addition sign. Now, there's something I have to do here. I can't subtract a negative number in parentheses. So I have to add the inverse. 8 plus 3 is positive 11. 11 plus negative 11, or 11 minus 11, is 0. 0 does not have the same value of -22. Therefore, A is incorrect. Here I'm just adding and subtracting, so I'll work left to right. However, here I do have to change so that I can add the inverse. Inverse means opposite. The opposite of -8 is +8. Now I can do some things. -3 plus -2 is going to give you -5. -5 plus 8 is going to give you +3, and +3 minus 1 will give you 2. 2 does not have the same value as -22, therefore it cannot work. Let's keep going. According to PEMDAS, we must work with these two first. -6 times +2, different signs will give me a negative product. That will give me -12 minus -15. We can't do that, so we have to add the inverse. Add the inverse. -12 plus +15 will give you +3. +3 does not share the same value as -22, therefore it does not work. By process of elimination, D is going to be our answer, but we're still going to solve it, and we're still going to follow our PEMDAS while we do that. So we're still going to do our multiplication first. Different signs means we're going to have a negative product. -5 times 2 is -10, and -10 minus 12 will give you -22. So that's why that's the answer, and that's why that one works. Okay, number 5. There's 3 different answers, or 3 different things to work out here. We have -7 plus -9. I always try to view it as money. You just spent $7 and you spent $9 more. So how much money did you spend in total? Well, you spent a total of $16. Because you spent the money, the answer is negative. When we get to our middle problem, we have that same situation that we had in question 4, where we cannot subtract a negative number inside parentheses. So we add the inverse -7 plus +9 will give you +2. Now, our bottom problem is the answer is going to be exactly the same as our top one. They can be written the same way. This is saying -7 minus 9. Well, if you were at -7 on a number line and you went back 1, 2, 3, 4, 5, 6, 7, 8, 9, you would simply be or land on -16, and that is how you solve those answers. Number 6, a team of 4 players competed in a golf contest. The names and scores of the players on the team are shown in the table, and the team score is the sum. Oh wait, my bad, wrong one. Sum means to add, okay? The sum of all the scores in the table. So we're going to set this up in a way that kind of makes a little bit more sense. We have -2 plus 3 plus -4 plus -1. Okay, so this is how we can write it. We're going to solve this, and I can show you another way to write it that's a little simpler. But because it said sum, I'm adding all of these values. The sum of -2 and 3 is +1. +1 plus -4 will give you -3. -3 plus -1 will give you -4, and that is our answer. That's how we find it. Another way you could have written it is -2 plus 3 minus 4 minus 1. It's shorter. It's a little bit more simplified. It means the same thing. Okay? Now, let's keep on going. We're almost there. Okay, for this next one, it says write an addition or subtraction problem that is modeled by the number line below. So the biggest thing we have to understand is that we always start from 0, okay? Now if I go to my 0, my first little tick mark is not there. It is here. So if I'm writing an addition or subtraction problem, I'm going to start with the number 2 because that's where my beginning is. Now I'm moving to the left, which means I'm going to be going into the negatives. If I'm moving to the left, then I'm going to be subtracting. And we're going to figure out by how much. 1, 2, 3, 4, 5, 6. Okay. So right now I have 2 minus 6. But now above that I see an arrow going to the right. And if it's going to the right, then I'm moving in a positive direction. So how many spaces did I move in a positive direction? 1, 2. Plus 2. Now, for the sake of solving it, 2 minus 6 gives you -4. -4 plus 2 gives you -2, which is exactly where we end up. So it works out. Next page. Okay. Now, let's go with what do you read? A submarine's elevation is 14 feet or negative 14 feet relative to sea level. All right, that's a weird way of just saying it's negative 14 feet below zero. So I'm not quite sure why they wrote it that way. But that's what it means, relative, right? How close is it to sea level? A shark is swimming at an elevation of negative 56 feet, okay? What is the difference? Difference is a big word in math because difference means to subtract. Now that's going to be important. So what's the difference in elevation? Okay. So negative 14 minus, because we're finding that difference, negative 56 feet. Now, it's interesting because there's something we should be doing to that minus negative in parentheses. If you're saying that we have to add the inverse, then you'd be correct, okay? Now, because 56 has a greater absolute value, which means distance from zero, we know, and it's a positive value, we know our answer is going to be positive. And because we know our answer is going to be positive, we can take this 56 and just subtract 14, and we'll find our answer. 56 minus 14, 2, 4. So the difference is 42 feet. Let's do another one. Okay. Number 9. Okay. It says Mr. Arnold has $50. Okay. Cool. He went shopping and bought 8 pairs of socks for $4 each. So he had $50 and he bought, right? 8 pairs of socks, and each pair of those socks cost $4 each. This means we're multiplying. And he bought a sweater that cost $11. So we must solve this PEMDAS, okay? Because we are multiplying, that does come first. 8 times 4 will give you 32. We still have our original 50 minus 32. And then we're going to continue to subtract the 11 to find our actual total, how much money he has left after shopping. Okay? So we'll go up here and we'll do 50 minus 32. We know that 2 can't be taken from nothing, so we must go next door and borrow. That's a 4, and that becomes a 10. 10 minus 2 is 8. 4 minus 3 is 1. So we're done with this first part here, but we still need to subtract that 11. We'll do that here. 8 minus 1 is 7. 1 minus 1 is 0. Therefore, he has $7 left after shopping. Okay, for number 10, which of the following expressions has the greatest value? Okay, we don't need any PEMDAS here, but we do need to know that in order to solve certain things that we need to add the inverse. So we're going to give it a shot here. -3 plus -4. I need to add that inverse right there. So -3 plus -4 will give me -7. And -7 plus 2 will give me -5. For B, here I have to change my inverse and change my inverse. -3 plus 4 will give me 1. 1 plus 2 will give me 3. Now, -3 plus -4 minus 2. Okay, so -3 plus -4 is -7. -7 minus 2 is -9. And for D, we have to add our inverse here. -3 plus 4 is 1. 1 minus 2 is -1. Which expression has the greatest value? The only positive number that we have is B. All right, let's keep going. Number 11. So number 11 is not so bad. In case you are unaware, whenever we have pictorials like this or models like this, the dark colors represent our negative numbers and the lighter colors represents positive numbers. So in this case, we do have -3, and in this case, we do have +7. So we're going to look at our answer choices and see if what we need is there. -3 minus 7, that's +7, so that won't work. -3 plus 7, that does work, so I'll put an M by it just in case. -7 plus 3, that's a positive, that's a negative, so no. Here we'd have to add the inverse, plus our 3 is a positive, this would actually be 10. That is not going to work for us. Our answer choice is B. All right. We got a little bit more. This is a long one, but it's worth it, okay? Here we have write an expression that goes with the model, right? Write an expression for the model below. Not a problem. How many skip jumps are we making? 1, 2, 3. What direction are they going? -2, -2, -2. So this can be written as 3 times -2 equals -6. All right, for quotients, it's -30 divided by +10, opposite signs, so our answer, or our quotient rather, will be negative. Here I'll do 30 divided by 10. 10 can fit inside of 30 3 times. Therefore, for this answer, our answer is -3. 31 divided by -31, we have the same sign, so that means it'll be a positive answer. 31 can fit inside itself 1 time. Therefore, our answer is +1. Same sign, so our answer is going to be positive. We have -121 divided by -11. That's going to be +11. 11 times 11 is 121. All right, let's keep on keeping on. We have 14. Last year, the temperature in Rochester, New York dropped. That means it continued to go down from -3 degrees to negative 21 degrees in only 6 hours. If the temperature changed a steady amount, if it's changing a steady amount, that means that we're going to have to divide at some point. How much did it change each hour? Okay, so it dropped from negative 3 to negative 21. We're going to find the difference between 21 and 3. But because it went from a negative to an even further negative, our answer will be negative. So 21 minus 3 is going to be 18. But we're trying to figure out how many degrees each of those hours it actually changed. It changed 18 degrees in 6 hours. So we're going to take that 18 and divide it by 6. 6 can be multiplied evenly into 18 by 3. Therefore, it changed negative 3 degrees Fahrenheit each hour. All right, let's keep going. Okay. 15. Which expression is not evaluated correctly? Not evaluated correctly. So we're looking for the wrong answer, okay? Different signs give us a negative product. 5 times negative 3 is negative 15. Therefore, that does not work. Different signs give us a negative answer. Negative 2 times 3 is negative 6. Therefore, that does not work. Any number, whether positive or negative, times 0 is 0. Therefore, that one works. We can't use it. Same signs means we have a positive answer. So because this is wrong, that's why we're looking for it. Number 16 says Amy bought 3 pounds of lemons at $2 per pound. 3 pounds of lemons at $2 per pound. That's going to look like 3 pounds of lemon at $2 per pound. It says she also bought a box of rice for $4 and 7 frozen dinners for $3 each. And 7 frozen dinners for $3 each. Now, in this particular case, we must follow our PEMDAS, which means we are working on this and this first. 3 times 2 is 6. 7 times 3 is 21. And we're going to bring down the rest, our plus 4 and our plus 7. 6 plus 4 gives you 10. Or wait, plus our 7. I'm tripping, sorry. My mistake. 10 plus 21 gives you 31. So the change in the amount of money she had was $31. All right, let's keep going. We're almost there. All right, same thing. PEMDAS. PEMDAS says that if we have division and multiplication in the same equation next to each other, one doesn't necessarily go first. You just work left to right. So we're going to take our negative, or our 24 divided by our negative 6. That's going to give us negative 4. We're going to multiply that by our negative 2. Negative 4 times negative 2 will give you positive 8. Positive 8 plus 7 will leave you with 15. Negative 9 times 0 is 0, plus 8 times negative 5 is negative 40. Negative 40 plus nothing will remain as negative 40. Now, oh boy. For 19, we have our true and false. Difference, mean we're subtracting. sum, adding, difference, subtracting, sum, adding. Now, they're saying the difference between two negative numbers is always negative. That will be false. If I have negative 3 minus negative 2 or 4, then I would have to add the inverse, which would give me a positive answer. They're saying it's always negative. That's why it's not true. Here, the sum of two negative numbers can be positive. That is also false. I can't say negative 3 plus negative 3 will give me positive 6. It won't. It's just going to continue to give me a negative number. For the third one down, it says the difference between two positive numbers can be negative. That is true. If I got $5, difference is subtract, but I spent $10, I now have a balance of negative $5. So yes, the difference can be negative. Now, the last one says the sum of one positive and one negative number is always negative. Well, that's also not necessarily true. The sum of one positive number and one negative number is always negative. So if I say 10 plus negative 9, I get positive 1. Guess what? It's not always negative. So that's just not going to work. That is false as well. Moving on to the very last one, it says show the following situation on the number line. The temperature was 2 degrees below 0. The temperature dropped 3 degrees. What is the temperature now? Okay, so if the temperature was 2 degrees below 0, that's going to look like negative 2. And if the temperature dropped 3 degrees, that means it's going to go down by 3. So I'm going to start at 0, negative 1, negative 2. And then it dropped 3 degrees. 1, 2, 3. The temperature now is negative 5 degrees Fahrenheit. That's it, y'all. Thank you.